Hey,
Josh.
Shay.
Okay.
Happy New Year.
New Year.
Okay. So, welcome back to the CDM. So this is the very first CDM of 2018, and we have a lot of interesting things to discuss tonight. The CDM is happening on APAC-friendly hours, which means that we have a lot of people here, including Brad and our mates from Australia, China, etc. Okay, so checking the tracker, I see that Sage posted the 2 different topics, and also, gentlemen, another one, and there's a topic there which I probably not listed on the. I mean, I don't see the author, but probably Sage did that.
I'm not sure.
Yeah.
Chime in.
Sage.
Yeah, anybody feel free to add topics.
Yeah. Full time.
All right, I can do the mon config stuff. Relatively quick update. Actually, nothing much has changed on that code in the last couple of weeks because of the vacation holidays and been distracted with other stuff. But the short version is what's there so far is the basic code that stores config on the mon in the config key. And there's a class that, here, let's see if I can find Etherpad. This is the right one. Yep. So there's a structure in config key prefixed by config that you store all the config options. You can have global ones, you can have them by daemon type, you can have them by specific daemon, and you can also filter by crush location, and you can filter by device class, for example, for OSD, so class, SSD, HDD, and so on. That's what's supported so far. And there's a class in the monitor that basically parses that information and stores it in memory, indexed by those categories, so that it can generate the config for any given daemon based on OSD.12 or MDS.A or whatever it is. And then there's a new message that can be sent to or from the monitor that just has your configs, the config options. And when the mon client connects to the monitor, it can subscribe to its own config. And then the monitor will send it the config effective for that client. On the client side, on the daemon side, the config code, config.h and config.cc is rewritten, not rewritten, half rewritten, so that for any given option, there are the config options can come from either the compiled and default value, the value that came from the monitor, a value that was parsed from the config file, or an option that was passed on the command line or via Ceph daemon config set or inject args. And there's sort of a priority value associated with those values, and it stores all of them in memory. So when you go and you get a config option, it just looks at the highest priority value for that particular option. And if you do, the config diff command has been, this output has been sort of restructured so that for any given option, it shows you what the different values are for that option, and then you can see which one is the actual effective one. So you have sort of full transparency of what the options are actually being used and where they came from, whether they came from the monitor or not. And then the last thing that's sort of being worked on right now is when you first start up the process and it goes and it parses the config options and the config file and so forth, it will also open a temporary session to the monitor to fetch the monitor config and then shut it down as part of the startup sequence. So on startup, when it loads all the config option, that includes fetching the monitor config, and then it proceeds with its normal setup. So that allows you to have basically almost pretty much any option in the monitor config, even like MS type. It won't affect that initial fetch config for monitor temporary state, but you could have it affect everything else, and then the daemon will start up normally. And the idea there is that Eventually, we might use a different channel for that fetching the config. We might do it over like HTTPS or something. It doesn't actually use authentication. So when it gets the monitor will already let you see the mon map without authenticating. It will also let you fetch the config for a particular daemon without authenticating. So the assumption is that the config isn't sensitive, which hopefully is true. I can't think of an option or a case where it wouldn't be, but we should probably.
That includes like file paths, doesn't it? Usually.
The config is file paths
and IP addresses. Yeah.
Yeah. Yep. Yep. So on normal systems, ceph.conf is world readable. So it's sort of the equivalent there, except it's on the network. Yep. That's the current thing. We could opt not to do that, and previously we were considering doing a more restrictive thing where there are just a bunch of options that you can't set via the monitor because they affect that initial setup. So all the like network related things like public network and MS type and all that stuff, you just have to put in config files. And if we did that, then we could authenticate with the monitor before we get the rest of the config options. But I thought this was probably better. We could add authentication to this step also, but I'm not sure if it's.
How much extra overhead would there be though? Like how much extra time does this add to start up of a Ceph command?
I didn't actually time it. I don't think it's that much because there's no authentication, so it's like like one message back and forth. It's like
just the setup and tear down of the messenger and stuff.
Yeah, and I don't think that's slow. On the client side, certainly it's just opening a socket and opening a TCP connection and including.
Does it apply to daemons or clients too?
It applies to both.
Okay.
Yeah. Yeah. So in order for it to work, that means that whatever the default is has to be enough to be able to open an unauthenticated session to the monitor. If it's not, then you have to add some stuff into the Ceph.conf so that you can get past that stage.
Isn't that insecure? I mean, for example, if a user has the access to the one Ceph cluster and then suddenly it decided to change the configuration of the monitors for his cluster to some artificial ones, isn't it possible to connect to others' monitors and grab their configuration?
Yeah, so currently it's unauthenticated. So yeah, you can connect to another cluster and look at its config also. So I guess the question is that a concern? Is there anything in the config that's considered sensitive?
It might be sensitive information for cloud providers. They might have different clusters for different clients, and then they might be on same network, so it might be dangerous for them.
Yeah. Okay. So it seems like there are two options. One would be to use all the normal Ceph authentication in that initial exchange. And that wouldn't be that hard to do. The other option would be to choose a totally different sideband way of connecting to the monitor. That's just totally separate. But then we would have to have that would have to have its own authentication. So it's probably easier just to reuse the monitor, I'm guessing, authentication. I mean, what if, I'm trying to think what other.
Is there a downside to just you doing that? Like, why didn't we start off that way? It seems easier.
Because I wanted it to be fast and lightweight. And the more, once you start adding an authentication, then there are a whole bunch of config options that affect authentication potentially that then you can't control via the monitor. you have to put them in the Ceph.conf.
Hmm.
So like the more special it is and special purpose, the less it overlaps with everything else. But it also means making it different. So I mean, another option would be like maybe it's just an HTTPS connection, like you just get a GET, and it just gives you the config, and we use like, HTTP auth or something else, some other authentication there. That seems, I'm not super excited about like inventing or like coming up with some other authentication that we can hopefully reuse the existing authentication keys. But
All you
that would
actually
be one option.
all you actually need is the keys and the monitor IP, which are going to be like
Yeah.
a setting anyway.
Yeah.
I mean, if you're getting into advanced stuff, then it seems like, I mean, you can just sort of have you can allow the baseline authentication for grabbing configs, and then more
Anything
complicated
more advanced. Yeah.
workloads. And
could we just encrypt and decrypt the config payload, the actual data?
That's an option actually. Just encrypt the config data with whoever's key is that you're requesting it.
Yeah.
Could do that too. It's
that's better.
it's like a special different thing, which I'm a little bit worried about, but it would.
Well, it's another attack vector because if you have any of the keys, you know basically what the contents are, so you can start asking for them and pretending to be other people to break open their keys.
You can put like a nonce in there so it doesn't.
I mean, you've got too much plain text. You need, right? If you put in a nonce, you still know what all but one nonce's worth of the data is, and so that's enough to do a text attack, I think.
You see the initial.
Very likely vulnerability,
Yeah.
but it's just when we start talking about encrypting things, that's
Yeah.
That's just maybe a separate key that was just for reading the config value that you would just deploy everywhere.
Yeah. I want it to be as simple as possible.
Yeah.
And so reusing the existing key is appealing. It also means that you can only look at your own config, which is kind of cool. So you'd accomplish the same thing if you went through the authentication process and our protocol actually was encrypted in the first place, which it should be, and hopefully someday soonish will be. Which makes me think it might be better not to do a one-off encryption just for the purposes of fetching configs, and to leave that part of orthogonal. Which makes me think that probably the way to go is to just do a full authentication before allowing you to read the configs. And it just means that we need to make sure that the default built-in options are going to work for enough people. And if you stray outside that, then you have to, put extra stuff in your local Ceph.conf, which is probably fine. Okay, well that's probably the thing to do. Where I basically ended up was I got that working, not doing the authentication part, but just doing a temporary setup teardown of the monitor connection just to fetch the config. I got that working, but I did it by like pasting 5 lines at the beginning of Ceph OSD, Ceph MDS, Ceph Mon, whatever, not Ceph Mon, but all the other ones, which kind of sucks. What I would like to do is actually put it in the normal global init, common init sequence. But it's annoying because the order that all the config stuff is parsed and done in that sort of mess of like initialization functions isn't quite right. I have to move things around a little bit. but it'll probably end up better once I do that. So I think that's the next step. So then there'll just be a flag. So there's already a flags field for common init, so you can have a flag that like says don't fetch monitor configs. I was thinking we could also add a command line argument like --no -mon-config to like skip that step. If you're like running, Ceph object store tool locally and the monitor's down and you just want to proceed, then you can skip that. But by default, things would do it. So that's the current status. I think the stuff left to do. I make a list here. To do is authenticate for initial fetch of config. There are no ceph config ... CLI commands yet. So the idea is that instead of doing ceph config key set and then knowing this like weird naming scheme, you would have something like ceph config set mon.a foo_bar and ceph config at global this that whatever, and it would actually look at its own understanding of what the config schema is, and it would do validation and give you errors if you have something that's out of range and all that stuff. It would do as much checking as it can. And there'd be like a ceph config show on OSD.12. That one I think I implemented already. I can't quite remember. And it'll show the running config versus the config. Maybe it just shows the running config. I can't quite remember. I have to go look at it. So it's a little bit wonky. As part of the manager session, where each daemons are reporting back their perf counters and stuff, they're also reporting their running config. So the ceph config show command is implemented on the manager, and it'll tell you what the running config is. But it can't currently compare that to what the monitor says. So it doesn't, it'll see what the daemon says its config is and whether it comes from the monitor or not, but it doesn't like fully validate that against what the monitor said. So if there's something lost in translation, like say the monitor says, option that does not exist equals 12, that won't make it all the way through. You won't see that from config show. So I'm not sure whether we want to also have the manager like look at what the monitor intended to set and compare that as well. Do you guys think that matters, or am I making sense? Do you understand what I'm saying?
Yeah, I think that makes sense. In the short term, at least, when people are likely to have more ceph.conf values still around, maybe.
Yeah.
I'm guessing it'll just be less useful later once people have less local ceph.confs and it's all centralized.
Yeah.
Fine.
So one thing you haven't mentioned that we talked about was requiring that the configs be set a certain way and not letting daemons join the cluster if they're not.
Can you remind me what that was?
Well, like when you join, you report your config to the mon, and so the mon might reject you if you don't have the right config. The reason being that we have a lot of timeouts and things that need to be, agreed on. And mostly we just cross our fingers right now, but occasionally people have gotten into trouble, and it would be great if we could stop letting that be a thing. And I mean, we'll hold on later, but it seems like that's something we want to design into the data structures and things.
So we could do that. It means that I think it might need to be like a per daemon type sort of thing, though. Because what's happening right now is that as part of the manager session, every daemon is reporting its running config. So the manager is going to have sort of full visibility of all people in the cluster, including clients. Maybe not clients. Whoever's reporting state to the manager, it will see their config. but that all happens separate from the initial part where like an OSD sends a boot message and gets added to the OSD map. So I think if we wanted to do what you're talking about, we would add to the OSD boot message the OSD's running config.
Yeah.
And then as part of the boot process, it would do its own special validation of specific options. We do something similar for the MDS.
Yeah.
But I think that's something that we would add on wherever we want to later. It doesn't really align with the other pieces. It also, it's worth pointing out, reminding people that this doesn't cover the monitors. The monitors currently have their full ceph.conf in the file. We could have some of their options be pulled out of oh no, I take that back. The monitors also pull stuff out of the config database and apply it. But we need to go through and annotate. So annotate conf only options, like Paxos star, for example. Things that you can't set via the mons because they sort of affect the mon's ability to function.
Are there still some of those that are used by like systemd on the OC side, or Ceph disk or anything like that?
There's stuff used by Ceph disk, although that list is shrinking. The systemd ones aren't used. That's already all been moved into the Ceph OSD process itself. There used to be that pre-start script that did random crap, and that's all done by the daemon itself. So that script is sort of obsolete now. And there used to be like max open files for the sysvnet stuff, and that's all gone. So it should be pretty.
Wait, so why does the monitor have configuration only options?
Because you don't want to set, Paxos timeout interval through Paxos, because you could break it. You could break the cluster if you allow that.
Not
it would be possible to.
As long as you can override it by putting it in the local config, then you can just override it if you do that. And in the meantime, you don't need that you have a small, like if you add monitors to the cluster, you don't need to make sure they have the same config as all the others.
Yeah, as long as they can work well enough that they are able to join the quorum and get the latest. Yeah, that's true. Yeah.
I means that they need the monitor.
Yeah, I mean, maybe it's just a matter of double checking that there isn't anything in there that really shouldn't be done. Yeah.
Because I mean, they pull all this stuff before they're allowed to do anything. So
that's true. For the sync, yeah.
And until after they've synced, at which point they know it.
Yeah. Yep, that's right. You're right. Okay, so maybe we don't have to do that. That's good. And then, incorporate into global init common init infrastructure. That's all magic. And then there's all the dashboard. Purpose on dashboard. I think that's it. And I think the Ceph config ... CLI stuff can go. I don't know, I guess we want Ceph config set, Ceph config get, Ceph config show. Actually, there's not actually that much to do there. I think I've already done set and show. So it's not that far from actually being usable. As part of that pull request, I changed as much as possible in vstart.sh to actually set all those random options through the mon so that it's exercised as much as possible. And I'll probably keep doing as much as possible there to minimize what the vstart ceph.conf looks like. That'll be sort of a good proof of concept. Okay. Yep. I got Any other questions on that one? All right, that's the update. The other update I wanted to do was just on the Kubernetes Rook stuff. There's no pad. Is there a pad? There's a pad on. We took a bunch of notes on the Rook stuff. It's kind of incoherent. I can link to it anyway. So basically, when we looked at Rook several months ago, it seemed very big and complicated, and it tried to like do everything for you and hide too much of the Ceph cluster. And so we looked at doing a lighter weight tool for deploying Ceph in Kubernetes. But over the course of doing that, we came to the realization that what we really need are custom controllers for the Ceph daemons, because all the generic stuff built into Kubernetes just doesn't fit what Ceph daemons need. So an example being monitors, you generally want them on different hosts, but in certain cases, maybe you want to, if you only have 2 hosts, maybe you want to have 3 on, I don't know, maybe you don't. And maybe you don't want to add new ones until if it's going to break quorum, and so they have to add them carefully, and you don't want to remove old ones until if they're going to break quorum, and so all these constraints around that sort of thing. Which is what why Kubernetes allows you to make custom controllers to do whatever you want to control the stuff, which is basically what Rook is. Another example is, during cluster bring up, you want to create the monitors and then the managers, and there's like an order that you do to bring all these things up, and distributing keys and all that stuff. So that's another example of what the controller operator would do. And probably the best example would be an upgrade. If you're moving from Luminous to Mimic, there's a certain sequence of operations that you want to take to upgrade the cluster, and you need to like have guards and gates and checks between those stages. Sometimes there are one-off things you have to do, like setting an option and waiting for the cluster to do whatever. Upgrades are always sort of tricky, and so until now they've been a checklist of items that the admin has to do manually. But in order to automate that, you need something that sits outside the cluster and knows how to pull all its strings. And so what we basically realized is that we do actually want an external operator controller to operate the cluster. And that's what Rook is. It isn't written exactly the way that we probably would have written it had we learned and known everything that we know now, and we're writing it from scratch. But it's much closer than what we have, which is nothing. And it has a existing user base, and people like it, and it works pretty well. And there are people also who are already working on it, so there's a existing community and so on, whatever. So long story short, we're looking at using Rook to be the tool to deploy Ceph in Kubernetes. We had a really good meeting with them the week before Christmas, basically going through the list of things that we need to change. Things like, one OSD per container, making sure that in the container image itself is using upstream images, and inside looks as much like a default Ceph cluster with default paths and so on. A whole laundry list of like random stuff to just sort of clean up and fix so that that it works, like naming the container pods so that they match the daemons, so that you can easily find, that one of the so that the cluster is actually manageable once all this happens. So we have a list of tasks that we're sort of working through. The first one that Sebastian's working on is just getting the container image sorted out, and I think the next one will be separating it out so that each OSD runs in its own container and can be upgraded and restarted and created and deleted independently from the others. So that's exciting. The sort of the joint goal that we set with the Rook folks was to aim for a 1.0 release of Rook that coincides with the Mimic release this spring. That sort of will deploy Ceph Mimic the right way, and does all the stuff that we need and want it to do. So that is also kind of exciting. But yeah, lots of work to get there. So definitely looking for folks who are running playing with Kubernetes, and we're trying to run Ceph in Kubernetes to get involved in that effort. Anything else? Anything else I should add? Dan, can you think of anything that we should mention?
No, not without getting pretty deep into it. No.
Yeah. Okay.
So,
Yeah.
there any attempt to unify the way we deploy this compared to the way we deploy a bare metal cluster? In other words, wrapping
No.
Rook in Ceph Ansible or anything like that?
No. There's going to be, there will be an Ansible playbook to deploy Rook and tell Rook to deploy Ceph, but it's going to be like super simple, and it's going to live in the OpenShift Ansible playbook. So that as part of OpenShift, you just sort of add the little thing that says deploy Ceph too, and it goes and it does it. But it's going to be pretty thin because basically it's pretty trivial to deploy the Rook operator, and then you have one like YAML stanza that says create me a cluster that looks like this, and it'll go off and do it. So it'll be yeah, it won't be the same as Ceph Ansible, which is both good and bad. It's nice because we can sort of shed all the legacy stuff. Like Ceph Ansible has already grown all these like different scenarios that it needs to support, whereas this one will be much simpler. It'll be all Ceph volume for managing the devices and so on. So, and then to the extent that the Ceph dashboard is going to allow you to manage the cluster, to like deploy OSDs and so on, it will be reaching back out to Rook to tell it to do those things. So when I'm not sure exactly how we're going to scrape information about like what nodes are available and what devices are not used or whatever. I'm not sure what that path looks like, but to actually tell it to go deploy an OSD, it'll basically be running kube control and telling Rook to go deploy an OSD. Is the plan. And I think that's the right model. So all the logic about how you run Ceph in Kubernetes lives in the Ceph operator for Kubernetes called Rook, and Ceph just worries about Ceph, except for the dashboard, which is going to have a few select hooks to reach out to its environment to let you manage these things. And the expectation is that that limited subset of things, some of those will have sort of alternates that will work on bare metal too. So for example, to like list devices on a system, we might have the manager able to just like SSH to a host and call Ceph volume list, or call out to Ansible to do that or something. There'll be some other alternate path that could be implemented and probably will be implemented in the course of this. But the focus is primarily going to be on the Kubernetes side, at least for the Red Hat folks who are working on it. One of the things that's always bugged me is that it's always super annoying to like go, OSD 37 is like messed up, and so you have to go OSD find and figure out what host OSD 37 is on, and then you SSH to that host and sudo and go like look in the logs. And I was worried that this is going to add another layer of figuring out what container it's in and then going to that. But I think actually it's going to get simpler because you'll be able to just run kube control enter OSD-37.ceph.cluster.local or whatever the pod name is, and it'll just drop you into a bash prompt inside that OSD's container, which will be kind of cool. So, yep, that's the short version. Any questions about that? All right. Jason, want to talk about easy clones?
Sure. So the goal of this is basically if you take OpenStack, for example. There's a lot of logic and a lot of crufty code for handling cloning images where it needs to create a snapshot, which is no big deal. You're gonna have to keep doing that, but protect it. And then if you clone it, and then what happens if you want to delete that parent image? Well, it starts renaming snapshots or renaming images to like delete me or something like that. So as part of a long-term effort to help end users like that clean up some of those operational issues. So with Luminous, we added the initial hooks for RBD trash. So even if an image is in use, you can still delete it. You move it to the trash, and you can, once all the references to it are gone, you can fully delete it. But to continue along that path, it would be nice also to clean up and how we handle snapshotting and clones. So basically avoid the need to protect or unprotect snapshots. Just create a snapshot and you can instantly create a clone from that said snapshot. And you can also delete that snapshot, but behind the scenes, RBD is keeping that snapshot alive because it's still in use for a clone. And obviously I wasn't here involved in the Ceph project when the current cloning and protection logic was done, and how it's currently done is with the RBD children object, where that's how it stores its links. And I always assumed that was just because you wanted to be able to say, well, you only have read-only access to pool A, and that's where your images are. So you can't write to that pool to say that you have a link to to a child in this other pool that you have read-write access to. So assuming that was the main limiting factor, what I was proposing as the first step for this is to expand the OSD caps. And there's already this notion of class allow in there, which I don't even think anyone uses. But to actually finally use that, but use it in such a way where you basically say class, class name like RBD, and then the method name that is permitted. So that way you can basically explicitly whitelist a command. So even if you only have read access to a pool, you can say, well, the cap says you're allowed to execute RBD method XYZ on objects prefixed, RBD header or something like that. So you can lock yourself down to a very specific thing where now you can say, well, any user can now invoke this method, in this case, like a clone add or something like that method that would inside the actual parent RBD image header that you only have read-only access to. It could then, atomically say, all right, now there's a reference to this clone over here. So now it knows that snapshot can't be, physically deleted while there's still a reference to it. But if the operator wants to delete that snapshot internally, it can do some stuff. We added supports in Infernalis, I think, I can't remember what release, for basically the snapshot namespaces. So most things that you see are always user snapshot namespaces. So what we could do if you delete a snapshot is now we can move it over to like a deleted but still referenced for a clone snapshot namespace. And there's already PR open that allows like the RBD CLI, like when you do a snap list, it only shows you user snapshots, but if you -- all, it will then show you like, oh, here's ones that are associated with like image groups or things like that. Or now in this case, this is a removed snapshot that can't be deleted until, children are deleted. So, I mean, that's the long and short of it. The biggest impact, obviously, other people in the system would be that change to the OSD cap to basically allow access on a specific class method, that you trust that class method and you're allowed to execute things on that. And we already added in Luminous, we had the profile RBD read only, so we would just append that on as something. So, all our instructions already say, when you set up a pool and you want read only access to them, say the cap is profile RBD read only. So now in the future, if Mimic or whatever release we add support for this, we can just tweak that profile and on upgrade, all the stuff would work.
That sounds like a great plan. I think this one kind of issue that might be annoying would be upgraded clients that don't.
The what? Yeah.
That are talking to an older cluster.
Yeah. So one of the things I was going to also, I forgot to add it, was there's other things, there's other issues. Like I don't want to keep adding feature bits for things that are associated with operations, because that just means now the kernel just needs to say, yes, I support it, even though it doesn't have to do anything, because it doesn't affect the layout of the image or anything like that. It's just, if you want to execute an operation, which is only librd, RBD CLI that knows how to do those things. So it'd be a new feature bit that says, this has a special operations cap, that you need to understand. So the kernel from that point on can just whitelist that feature and says, I don't care, I'll open an image with this operations feature bit. But operations going forward, same, because I want to do the same thing with grouping. Like if an image is added to a group using an older like RBD client, you shouldn't be able to remove that image if it's part of a group. But older RBD clients don't know that they have to go check that.
Right.
But I also don't want to prevent KRBD, to keep having to spin wheels of adding 30 feature bits for, various things that only affect librd. So older clients in this case, you'd have to have an upgraded client to manipulate an image that was using this new style cloning, but older clients would still be able to play with, read write from that image. They just wouldn't be able to like remove, the clone or something like that, because they wouldn't understand the feature bit the operation feature bit that is associated with it.
Yeah, that makes sense. I'm glad you added the RBD profile in the last few releases then, since that makes it a lot easier to upgrade this stuff too. I have to have everybody going and updating the caps manually.
Yeah, for a while though on the documentation, I was like, what are the caps you have to use? And it was like Google, because it wasn't actually in any RBD documentation. So I was like, well, it was in like the Ceph documentation on like getting started somewhere else, but like in the RBD doc, it didn't talk about like, you need to like whitelist RBD children or anything like that.
Yeah. Yep. Much better. Cool. Okay. Where's the thing?
And like I said, if no one is using that class, I can totally take that over, because right now the code didn't make any sense to me, because it was like class name and then the allows, but the allows was actually never even checked. It was just a freeform string.
I think it's nothing in trees, is it? To the extent that it might work, maybe somebody out of trees using it. I wouldn't worry about it. Yeah. Okay.
That's all I have.
Cool. Josh, you were going to talk about async OSD.
Yeah, so not much new from last time. I thought I'd just kind of reiterate for our audience, maybe we're able to attend the last CDM we're thinking about. So the general idea here is that we want to prepare Ceph for the faster devices that are coming out these days and will become more prevalent in the next 5 to 10 years. Things like NVRAM speed devices that end up being incredibly CPU bound with the current Ceph code. So essentially the model that we've been thinking about is a shared nothing architecture where an OSD is partitioned with different PGs being sharded across different CPUs so that we can avoid as much overhead of CPU communication as possible and get the most performance out of each individual core. This means that we don't need to do any kinds of or minimize any kind of locking or atomic instructions and CPU cache. It's all stays localized, but it also involves large changes to the OSD. So what we've been thinking about is using the C-star framework for building this out and rewriting the OSD in terms of C-star. C-star is basically designed for exactly this type of model, where you have entirely independent cores with all their data localized, and being able to work with very fast network and very fast storage devices, likely with things like DPDK or SPDK, which use polling to be able to keep up with the high rates of data transfer. This does imply a large refactoring of the OSD, since a lot of the OSD is not asynchronous at all. Much of it is still very much synchronous, with locks everywhere, and of course everything right now going to a shared object store backend. So I think the what we've been thinking about is to slowly convert the OSD kind of a bit at a time, starting with at the messenger level and then going through the data path to C-star asynchronous framework using their kind of futures-based model, where instead of having callbacks, you chain together futures. And eventually, in the longer term, actually making a new object store backend that is designed for fast devices and could potentially be sharded or have multiple instances per CPU or across other class CPUs. Since we're not likely to be able to use RocksDB or existing stores there, but that's kind of the longer term. I think in the not the Mimic timeframe, but maybe the Mimic and next few releases timeframe is probably where we want to get the OSD itself converted. And at that point, we'll be able to see probably a little bit of benefits in terms of just reducing the CPU overhead from the OSD I/O path itself. But the full benefits won't really become apparent until the entire path from the network all the way to the disk is there. That's kind of a broad overview of what we've been thinking about. Is there any questions people have, or? Anything else we should mention here?
I have a couple comments. I've been working on putting all of the other work into the work queue. So PG removal is about to merge, and then the peering events are going to be fast dispatch. And it's been a little bit annoying because that central sharded queue, the semantics are getting a little bit more complicated. But the code paths are much cleaner. It's easy to look at the code now and imagine what it's going to look like when it's sort of run to completion mode. Because in most of those cases, the code is sorry, my headset. In a handful of cases, we're also catching up on OSD maps. So it'll block or not block, but whatever it does. Wait for a future or whatever. Give a promise until it gets the data and then proceed. But it's looking pretty good. The last realization I had today was that I think there's currently still a central data structure that's the PG map lookup table. But there's an auxiliary one that's on each shard of the work queue that gets used in practice, so that you look at the shard local map and it also has a reference to the PG thing. I think I'm going to promote that shard to be a global first class item and have the PG map be the PG map. It'll just be sharded, and there won't actually be a single map that covers all shards. I think that'll simplify things. It'll get rid of one of the locks at least. And I think that's getting even closer to where we're going to end up, where we want to be with C-star. So.
Yeah, that sounds like a good plan to me.
Does that actually work out with split?
Yes. Yeah. Yeah, so split is annoying because a PG that's in one shard is going to fragment into a bunch of other PGs that are going to land in multiple shards. But the way that it works is currently there's I think is that Lu Chang, I think. Do you mind muting? I can hear your clickety clack. The way it works is the handle OSD map update, which happens outside of the sharded work queue, is the thing that is processing maps and getting them ready, and then delivering them to all the PGs by queuing events for each PG for them to update. And it basically, when it gets the new map, before it shares it with the PGs, it has an initial sort of prepare phase where it makes a list of all the PGs that are about to be split, that are like in the process of being split. And as part of that, it installs sort of a temporary entry for those PGs in those sharded maps with a flag that says, block the messages until the actual PG appears. And so I think that part will basically be the same. Once I'm done with this current push, the only thing left in the normal dispatch paths that isn't fast dispatch is going to be the OSD map updates. I'm not exactly sure how that's going to end up working in a C-star model. If it runs on any shard and it's delivering messages, it's using a message passing framework, whatever, to do all that. I'm not exactly sure how that's all going to work. It probably depends on how our OSD map cache structure works and all the rest. But at least conceptually, I think the sequence is going to be pretty similar. So.
And in the fully degenerate case, we could end up saying each core is a logical or separate logical OSD.
Yeah, we could also do that.
We can avoid doing that and then actually have the shared OSD cache, OSD map cache, for example. Yeah. That would probably help.
Yeah, it's interesting. I'm not really sure what the endpoint is going to be, because if the endpoint is that there will be no more than a single core dedicated to an NVMe, then we're wasting our time doing all the sharding, right? It's all just one. It's just one thing. And I think probably that's where we want to get eventually. But right now, we're using, for a single NVMe, we're using many cores. So I'm not really sure what the endpoint is.
I don't think that's actually going to be the solution we want. But in the worst case where we can't come up with something else, we can sort of internally segregate OSDs within an NVMe, right? So we can say, this one NVMe, and we're just going, it's invisible to you, but we really have 3 or 4 OSDs inside of here because that's how many cores there are for them. Because
yeah.
I mean, you can get into messes with hot plating and stuff, but really no, we have a static mapping of the number of cores versus the number of disks that are available. So
yeah,
that's sort of the emergency fallback is all right.
Yeah, and I mean that's actually what you do today to get the best performances. You have 2 or 4 OSDs per NVMe, so it's not that crazy. And once we're at a point where we're putting multiple logical OSDs in the same process, then it all works. But I don't think it's going to be that much more complicated than that anyway, because we're still going to want to have the shared OSD map cache and the shared messenger connections with messenger 2 and so on. So
no, I'm
not too concerned.
I had marked aside the OSD map as something that we still need to figure out how it works while I was going through and looking at things, but I was hoping to see how the split in how you got the split working before we tackle that.
Okay. Yeah, I mean it's using the same basic model that we have right now, where there's you ingest the map, you put it in the cache, and then you queue null events for the PGs, and whenever the PGs process that event, they catch up on. They sort of pull forward to the latest map. I'm not sure. Yeah. It seems like we have sort of a reasonable list of things that we can start futurifying. The OSD map cache is one. The messenger is a big one, but that's big. One is the logging framework. Have a variation of that that's sending the log passing references to the log messages or whatever. So we can use it from the C-Starry code. I guess that's a short list, but
Yeah, it still represents a lot of work, though.
yeah, yeah.
I think regardless of exactly how we end up, at least right now, it seems like we're going to end up with a single process. Since it's for the DBDK and those kinds of direct access frameworks, you need one process responsible for the network.
Yep. Yep.
Regardless of whether we logically separate OSDs with the different like OSD instances for core, or what we decide to do there, but
yeah. This is probably as good a time to mention also that at when we're in town for Ceph in March, we expect to spend a lot of time talking about this stuff on Tuesday and Wednesday with the XSky folks and also the Intel. A lot of the Intel people who work on DBDK and SBDK are based in Beijing. So you can probably expect to spend the full day Tuesday and Wednesday working with them on this stuff.
Sage, one thing I wanted to bring up that was kind of related to what we were just talking about before is, but maybe is still far out, is kind of how if we have these different kind of sub OSDs or even just have one big OSD managing a bunch of different disks, is the cache and how we kind of reorganize that in a world where maybe there are things that we really want to prioritize caching versus other things like RGW bucket indices, right? You might want globally to optimize for these, to keep these in cache, rather than kind of having this division we do now where every single OSD is getting 3 gigabytes or whatever. Now maybe we don't divide that. Maybe there's an uneven division depending on what we need.
Yeah, I think in general we would expect that OSDs in the same class are going to have data distributed uniformly, and so they would have the same amount of memory.
Data might be distributed uniformly, but accesses might not be, right?
Yeah, you might have hot ones or cold ones. Yeah.
In the state box, you might have a bunch of hard disks with the data, and then SSDs with the bucket indices.
Yeah, but I think in that case you would set a config off. You could set a config option that applies to the SSD class ones. That's different. You have the device classes, and the new config stuff is going to let you do that. I think, in generally speaking, not speaking to that specific issue of like the fairness between OSDs, but in general, the caching situation is going to be better because, from what I remember with the conversation with Avi Kivity, the C-Star gives you better primitives for managing cache pressure in memory by being able to define I don't know if you call them reclaimers or reapers or whatever, similar to what the kernel does, where when there's memory pressure, there's like a callback that tries to claw back memory, and you can define those yourself, which will work better than what we do now, where we're sort of in this unbounded but high overhead, fragmented weirdness.
Well, I mean, let's be clear. That's talking about like disk caches and things that actually don't know where the BlueStar caches live, but and that's integrated.
Well, yeah.
Memory.
I'm thinking forward to beyond BlueStar, where we have something that is fully C-Star native, and so we can have a better managed in-memory cache, I guess. There's going to be a limited amount that we can do with BlueStar in this world.
Yeah. And on that note, Mark, it's a little easier for us to reallocate cache between OSDs if they're all running in process on C star, but not a lot. Because we can't, like the way C star works, you can't really dynamically reallocate the workload. I mean, like
The sharding is fixed.
I'm not sure if it's actually fixed, but even if it's not, that's not going to be like that'll be a thing if to try and allow it to resolve. And like memory, like it may be. I don't actually know. I'd have to look. It might even not be possible in the framework. It might have to like build a framework where we can say, oh, this core was willing to give up RAM and hand it off to that other core that's busier.
Yeah.
I mean, like that, like you could, if we wanted to, we could already do that with just like IPC of some kind, right? So it'll be a little easier because they're in process, and so we'll have like our inbuilt communication channels, but it's not.
It's also a little unclear to me whether large like memory caches will be incredibly important for almost memory speed devices.
Yeah, that too.
One of the things that just bit me, well, it's probably actually bitten me before, but I just remembered today, was how much it bites me when I'm comparing FileStore and BlueStore on a system that has a huge amount of memory with like NVMe, because FileStore basically gets the benefit of the entire page cache, whereas BlueStore has a fixed amount, and it's on something like an NVMe drive, when you have a lot of RAM, it actually makes a really big difference in terms of even like random reads. So much of the volume can end up being cached. So any way that we have, or any possibility in the future of being able to kind of have a more global cache pool to draw from, could be good if we can do it in some way.
Yeah, and it certainly does make it much more easy, much easier with a single process.
I mean, it kind of feels like at that point maybe we're recreating the VM layer in the kernel, but
yeah, I mean that's effectively what we're doing here, but moving as much into user space as possible.
Yeah.
Yeah, one clear benefit of having BlueStore its own cache is that we are not calling kernel syscalls anymore when we are reading from cache.
Mm-hmm.
Indeed.
So the C star effectively placing the kernel scheduler with user space one.
So with C star, there would be no reasonably easy way to do this.
I mean, it's doable. It's just it's not made easy to kind of reassign memory that's allocated on one core and then say, okay, now this other core is going to be responsible for it. I think it's certainly, I think it wouldn't maybe be hard to make it do that, but it's probably not ideal for performance either. So we'd have
you don't
to
get it for free.
Yeah.
Yeah. Presumably it would be something you wouldn't do really often, maybe. I don't know. I guess it depends on what we want to do, but
yeah, I think it would take some experimentation to figure out if it's necessary and to what extent we want to optimize for that.
Like part of what C-Star's saying is it tries to figure out the locality of memory, so that I can't remember the name of the system, so that you're using memory on the core, and not having to jump around between memory controllers to get it and stuff. So
yeah, we definitely want to respect that if we can.
Yep.
If we do something crazy here.
This isn't at the top of my list of concerns, so I'm not too worried about it. But
Yeah.
Sage, at the very least on OSD startup, can we kind of go with the idea that we allocate it based on kind of a division of the total rather than like having preset values like we do now?
I think that's a policy decision. It's a, we just decide.
Yeah.
I think you have to tell C-Star how much memory to consume. So you can
Yeah,
look at the
exactly.
available RAM in the system and just pick a number, but you're still taking exclusive ownership of that. So if you're sharing the node with other stuff, then you have to take that into consideration. So
Yeah. I guess more what I'm getting at is if we do have a single like Ceph OSD process controlling multiple drives, we set it at that level rather than at the individual like drive level.
Yeah.
Mm-hmm.
I mean, I know it's really basic and really. Yeah, I just want to make sure that that's kind of the thinking that we've got. So we're okay.
Yeah.
Cool.
Really aren't there yet.
Yeah.
That's the whole second phase that I think we'll follow after we've done a much more conversion than we have so far. Although Sage's comment about the memory brings up something else I think we haven't discussed, which is that C-Star is not very good about sharing. Like you can tell it to use only a certain number of cores and only a certain amount of memory, and it recently gained the ability to not do 100% CPU burn polling when it's idling. But that's a very new thing that they told me.
I don't think it was that new. It was like a last year thing.
Well, yes, last year was 4 days ago. I think it's
Oh.
he said it was in September, actually, or like late summer or fall. My recollection, but maybe I'm misremembering. But it is not well tuned though for sort of like running where a lot of the world inside of the process is running in C-Star, and a lot of it is not. Like we're gonna have to do with Blue Store. So that's gonna involve us like making changes to the framework and hopefully pushing them upstream as configurable options and stuff, which will be exciting for us.
Yeah. Hopefully nothing too crazy, but we'll find out, I guess.
Mm-hmm.
So
Other
that
than
things like actually maybe we'll just disable C-Star's memory allocator for a long time.
I wonder if it would make sense to write a C-Star mem store.
Yeah, I think we talked about this in the perf meeting a couple of weeks ago or before the break.
Okay.
don't they have one? Didn't Casey and those folks make one or something?
There's a mem store. It's not C-Star defined.
Yeah, Matt says in the chat a primitive one.
Okay.
There's something. It's early days, but there was something started out that way.
And I remember hearing a discussion about it with like the not a messenger plugged in, but I didn't think it was.
No, well, there was two things. There was part. Casey was kind of working on the Captain Proto throwaway thing, and then but Adam was kind of working in this direction from the other side. I don't know how advanced it is, but there is something.
Yeah. I'm kind of thinking that sooner rather than later we should have sort of a sub team of people start working on the new C-Starified SPDK based object store also. It feels like that can start pretty soon, as soon as we sort of have a better understanding of what the shape of the interface is. Even before that.
What do you want to accomplish with that? I mean,
I want it to be kind of ready by the time we have the rest of the data path ready. Instead of having everything ready to go and then being stuck with a wrapper around Blue Store for a year while we go and write the other thing. I think we can do them in parallel.
that sounds insane to me. Just because it's going to be another on-disk storage system that we need to have ready, and I don't think based on what we've gotten done in the last 3 or 4 months, I really don't think we have the bandwidth to do that at the same time.
That's why I said it maybe a separate team of people working on that, because I think you guys should stay focused on the OSD data path. But we can at least have the design discussions around what the other thing is going to look like, and if there are people who can start working on it, then that'd be great.
I mean, part of it though is that I think we're going to sort of come to understand what it should look like based off of what the rest of the system looks like, and I'm not sure we want to try and start designing it before we've gotten a lot of that.
Yeah, well, that there's it feels like the fuzzy area is going to be around what the interface looks like, but not the like structure of the data and the on-disk format and sort of how it.
Do you think you know what that looks like? Because I have no idea.
Well, yeah, I don't have a great idea, but we've had several conversations with Alan, and he summarized what he thinks it should look like, which was a pretty reasonably complete sketch. I just pinged him to see if I can share that description on the list or not, but yeah, I mean, it'll be like a log structured thing basically that's streaming data out to the NVMe and then uses looks more like a log structured B tree than a log structured merge tree. So it's more flash friendly. But I think that a lot of thinking can go into that sooner rather than later, so that we aren't sort of have things lined up.
Even just writing some kind of like C*-ified sharded log structured B tree without even having the interface, just going through the exercise of doing it would at least give someone on the team insight into what needs to come next.
And it seems like even if the interface is evolving wildly as we sort of learn what it should look like in a futures world, then like that's fine and probably good. I mean, we can use something like memstore as a stopgap, but I'm worried that it's not going to be quite right because there are going to be latencies involved with the flash that aren't there for memstore, and we need to have that asynchrony built in so that we're actually deferring control or whatever when we're doing an I/O and we're being asynchronous instead of synchronous, whatever the right term is for that in the futures model. But I think for now it's probably just sort of a whiteboard discussion about what we think it might look like, but hopefully it can move past that.
Sage, if we write that thing, is that something that is general purpose enough that the C* world can benefit from it?
That's a good question. I was sort of assuming that it wasn't, but when I mentioned it to Yehuda earlier today, he was like, oh, that could and possibly should be sort of a separatish thing. And it occurred to me that when we had that conversation earlier about whether there was an existing key value database that we can leverage that was C* based, there was nothing except for Scylla's AGVL thing. So it might be that this is an opportunity to make a native storage backend that can be reused by other projects too.
When I looked at their thing, it didn't look like it was anything you could really easily use as like a local key value store in the sense of like RocksDB or LevelDB either. Even if you could get the licensing constraints dealt with.
Yeah. And it might be that we end up in the same boat because it's sort of specially built for our needs, but maybe not.
Our needs are, at least so far, have been so kind of general though, right? I mean, it's really simple. It's straightforward.
And making something that can store key value data and blob data and as transactions, like feels pretty general purpose to me. It can certainly be used by a lot of things, although it might have more requirements than many things. But I think this is a good opportunity to collaborate with the Intel folks in Beijing, because they're clearly very interested in everything in this space, and I know that they have efforts looking at converting existing key value things and writing new key value things to work with SPDK natively. So I think there's good opportunities there. Okay. Anything else we want to talk about with C-star? I was thinking that for maximum confusion value, we can call the native C-star object store implementation C-store.
I like it.
Yeah, and we can use the letter C too, just to like mess with people, even though it's written in C++. Yeah, whatever. Anyway, okay.
How about C18 store?
Back to C store.
Yeah.
C18 store because it's written in 2018.
Yeah, there we go. Anyway, I'm sure there's all kinds of really bad options for naming there. Somebody put on here Tethology OpenStack status.
Yes, that's me. The story behind this is that for some time there was a project, Tethology OpenStack, managed by Loic. I don't see him anywhere right now, but he was maintaining it for a while, and even last year I was speaking to him and Nathan Cutler, and from what I understood, Suzy guys are maintaining it for now. But as far as I understand it, it's some kind of their own fork. And my question here is, what about Tethology OpenStack that originated at Red Hat? What's going with that?
So I never looked at the Tethology Open stuff super closely. I think it was a bit of a fork. And I don't know that it does anything where it went. So that's the bad news. The good news, though, is that we use Tethology today to test on OpenStack on OVH, and it works fine. So I think what ended up happening is that Zach re-implemented the pieces of it that were important, namely deploying the VMs and attaching Cinder volumes to them based on the job specification, and then running tests. So if in the current Ceph lab, if you specify the machine type of OVH instead of Smithy, it'll run the whole existing test suite on OVH. And it mostly works. We don't do it all the time, and so their tests keep sneaking in that don't have the additional annotations that say how many block devices need to be attached to the machine and how big they have to be. But assuming you do that, then it works. The latency is a bit different. I think the last time we used it in Anger, we kept hitting OVH issues where the Cinder attach failure rate was just high or something. I don't remember what it was. Yeah. And there's some timing issues where some of the tests just they're slower. Things are slower, and so the timing's a bit different, and so they fail for that reason. But it mostly works. So.
Right. So the question is how to use it outside of the Ceph.
Okay. That's a good question. The easiest thing is to use it inside of Ceph. We can give all of you all access, and so you can use it that way. If you want a truly independent installation, then I think you need to have a series of conversations with Zach to help get it set up, because I don't think there's a document that says how to install the whole Teuthology stack from scratch, because it's constantly evolving.
Yeah, so that was sort of the thing that Teuthology OpenStack did that was different with a way to actually run against OpenStacks. But the downside was that it was enough of a fork that sort of other things kept breaking. So I think Stack got all of the parts except for the independent setup. Either merged or re-implemented, but that I'm not sure if that one ever made it. I think it probably didn't, but
there is actually a document for how to set it up. I don't know how current it is, but it's actually written down in libcloud backend.
Mm-hmm. I mean, the really easy thing is that if you guys don't already have Ceph Lab access, we can add you tomorrow, and you can start scheduling jobs. And you can deploy more VMs and start adding them on there. And so I mean, you can do it now. But if you want to eliminate the dependency on the install in the Ceph Lab, then yeah, it'll be a bit of setup to do that. It's kind of nice having it be the same environment, because all the tests show up in the Pulpito same web view, so you can see all the results, and you can all the test results get archived in the same place. So it's kind of convenient to keep it centralized. But yeah, that lets you scale out the node count as much as you can afford.
The node count is one thing, and the another thing is that sometimes I would like to experiment with something, and it would be useful to just run some tautology jobs on that, so just make sure whether this actually makes sense, doesn't break anything important, and so on, before pushing out actual branch somewhere public and probably someone picking up from there.
Yeah, I mean, the way that Teuthology installs the code, it has to have the set of package builds, and so you still have to push it to Ceph CI to get packages that it installs. There isn't sort of a backdoor way to deploy code. So it'll be public in that sense. But yeah, I mean, that's what we do when we're working on a branch and we have an early version. We'll schedule a small subset of nodes on. We'll do it on bare metal, but you can run it on OVH too.
All right.
But yeah, we should talk more and figure out how we want to move forward.
All right. I think we can try something.
Yeah. Okay. Sounds good. Anything else that we should cover? We have a bunch of people. Dongjun, Lucheng, Youngwon. Any updates from you guys? All right. Sounds good. It's a wrap, I guess. See you all next month. Thanks for taking the time. Happy New Year.
Happy New Year.
Happy New Year.
See you guys.
Thanks, everyone. Happy New Year.
Yeah, 2018, the year of Ceph.
Yeah.
And the Linux desktop.
Yeah.
I know, that's what I was thinking. I was like, oh no.
Yeah.
Goodbye, guys.
Happy New Year.
Happy New
New
Year.
Year.
Absolutely.